Hello, everyone. Good evening, good morning, or good afternoon. Myself and Bob are here. Okay, the presentation is on.
Yep.
Very good. So welcome. I've actually lost some of the stuff. Okay. I'm doing okay. So, guys, thank you. Let's give it a few moments for everyone to log in. And today, let me anticipate that at the end of the presentation, we will answer some of the questions you have posed. Very interesting questions through the registration process, about 20 plus questions. So very, very interesting. So bear along to the end so you can see the answer to those questions. Of course, you can always ask more questions throughout the presentation by using the question and answer box. We just had a Zoom update and now it's in Italian, so it's domande e risposte. I don't know whatever. So Bob, let's go on. Let's give it a few moments for me to present GMI, who we are, what we do, so we can, of course, talk about Bob earlier. First, if you don't know who Bob is, he's our speaker for today. And, 35 plus years of experience in the EX world. He's a EX instructor as well as an instructor under the ECEX competency scheme, and it is an inspector. So, and a member of the US ULSTP committee, and work for a company that is involved with EX product and application all his life. So he's very qualified to be with us today. And I'm Paolo. I'm a sales manager for GM International. So I need to talk to you about GM International for a few moments before we start. Who is GM International? We're a safety company. We manufacture, engineer, and design a complete range of intrinsically safe and SIL certified devices, which are used in many automation packages such as DCS, ESD, SCADA, EPS, and so on. They're used primarily in oil and gas, but also petrochemical, pharmaceutical, mining, food and bev, and so on. We've been around for 40 plus years, and we are very proud to manufacture our product, 100% of our product here in our state-of-the-art facility near Milan in Italy. On the other end, we're a global player. We're present around the world. We have several subsidiaries, many channel partners. We are about 200 people. We have done thousands of installations. And let me see what next, Bob, because I don't remember. Okay. And we make safety products. So we take special care in manufacturing those products and designing, engineering. In fact, we are functional safety management certified up to SIL 3. So not only our product are SIL 3, but also our manufacturing, our designing, our engineering, because at the end, the product we manufacture make our planet safer and make your life safer. So we use state-of-the-art technologies, 100% traceability. We test 100% every single product we manufacture. We give 5 years warranty and 10 years availability. Next. And here are the certifications standing behind our claims. So, we have over 15 independent agencies that qualify our product and certify them. And of course, as I mentioned earlier, TUV, functional safety management, ISO 9000 for quality, 45,000 for OSHA, 14,000 for environmental management, across, reach, waste, a lot. It's quite a bit of effort, we have more people in certification and engineering. It's not true, but there are quite a few. These are the products we manufacture, IS barrier, which are up to SIL 3 certified, safety relay with and without line monitoring. They're also SIL 2 and SIL 3 certified. We have isolators, which can also be SIL certified, power supply, which ATEX and SIL certification carry. We have multiplexer, heart, temperature, digital multiplexers, surge protection device or SPDs, and some indicators, and a division which runs EX, SIL, and cybersecurity training courses, webinars like we're doing here today. Next, I think we have a list of our customers, or at least some of them. We typically sell to many system vendors or Mac, today we call them ABB, Schneider, Siemens, and so on, Yokogawa. Of course, we operate on many projects globally with EPCs. We have many OEMs which use our product in their machines, their ski, their compressors, drilling equipment, or whatever else. And many end user approve our product. I believe that was it. I tried to be very fast so you can spend the right time discussing what is an inspector looking for. Thank you, Bob. It's all yours.
All right. Well, thank you, Paulo, and thank you all for joining us today. This is always a fun topic to get into. We've done this before in the past, but we've added a little bit to it. And actually, some of the questions that were posed are absolutely brilliant. So I hope you guys can hang around for the Q&A, because I thought there were some really insightful, good questions that hopefully I'll be able to answer. As Paulo mentioned, we do quite a few different things, and part of our roles is also actually doing inspections. And I actually had my last inspection here about 3 weeks ago on an LNG fueled barge, doing a final detailed inspection. And the good thing is that a lot of the folks that actually had done the installations, we actually had trained as well. So I knew when I went up there that I wasn't going to hopefully see many issues, and quite frankly, I really didn't. So that was a good thing. But I do want to share with you today kind of what a traditional EX inspector is going to be looking for. What are the tools? What are the things that you can do if you're not doing the inspection, but you at least to have the knowledge to be able to sometimes either question what the inspector is asking, or to have a better understanding of actually what they're trying to accomplish. And the whole intent is the more that you know, even though you may not be an inspector, the more you know of what those inspectors are really looking for, the more things that you can catch ahead of time to make sure that the inspections go very quick, smooth, very cost effective, excuse me, and done in a way that really works out and maintains the safety for everybody involved. So why do we have inspections, right? Electrical installations in hazardous areas possess features specifically or especially designed to render them suitable for operations in such atmospheres. So it is essential for safety that throughout the life of such installations, the integrity of these special features is preserved. So when we talk about EX inspections, sometimes people think of it, it's just that one time, that final detailed inspection that we do. And then once we sign off on that, we put it into service, then it's done. And that's not at all actually the way we should be looking at this. Inspection should be an ongoing process. It doesn't necessarily mean that it should be a third-party person coming in and doing those inspections. But somebody within an organization, either internal or external, should maintain this inspections or continue these inspections, because things break down, things fall apart. We want to make sure that we're staying on top of it, because again, we don't want to wind up with any of these particular types of disasters that we see unfortunately occur all too often. So what is, if you will, the main standard that we follow? And pretty much everybody in the world will follow a relevant version of the IEC 60079-17. This is the base standard. It was last published in 2013, and from my understanding, I think it's going to be, well, they're working on it, and it will be actually probably updated sometime next year, that there'll be a new edition of the -17 standard. Within Europe, we take the IEC standard and it gets adopted by Senelec and becomes an EN standard, or a country-specific EN standard. Here in the United States, we've adopted this as a UL standard, and this applies to zone-rated equipment. And actually, for those of you who are familiar with the North American division concept, we're actually working on right now and hope to have it finalized, a North American inspection standard for division-rated equipment. And of course, in other parts of the world, such as Australia, New Zealand, they have a similar standard. Brazil, many other parts of the world have adopted, in effect, these 60079-17 standard in some way, shape, or form. And they're all based upon, again, the same concepts. We're looking at the same thing. So this inspection that I did here recently, this was done for a project that's going into the Gulf of Mexico. They were following the IEC version, but I did an inspection about 2 months ago that was following the Australian requirements under the 60079-17, which again, there were slightly different variations, but for the most part, it was the same process, if you will. So the good thing is that if you're doing inspections, EX inspections, pretty much around the world, you're going to be following, in effect, the -17 standard in some way, shape, or form. Oops, there we go. Now, just because we say to follow the -17 standard, one of the important things to note is many companies, as an inspector, I always want to make sure that I'm not only catching what the requirements are from what is in 17, but we will also have specifications that might be set out by our client. So when I've done work on the behalf of some of these major oil and gas companies, I'll ask for their project specifications, and I'll make sure I'll have this conversation with them to say, hey, what is it above and beyond the -17 that we also need to be looking at? It's maybe a specific project specific requirement. For example, we had one project here I did a while back that barrier glands were not required per the -17 standard for many different applications. However, this client said, nope, we require barrier glands regardless, so they should have 100% barrier glands installed. So we want to make sure that we're paying attention to whatever the specifications, because again, the -17 is the minimum requirement. And again, clients can go above and beyond that. So we want to be aware of that as well. So what are really the checklist before we get into the inspections? Again, what is the country regulations? What are the client specifications? What grade of inspection are we going to be doing? Or is it going to be a visual, close, or detailed? We need to have a bill of material. We need to have drawings. We need to have certificates. This is very important, especially when we start to look at things like X conditions for pieces of equipment. We want to certainly have an EX register, and we want to have a data sheet on all the equipment, including the installation operation manuals for all of this equipment. So we should hopefully have a fairly large document, if you will, before we undertake a true EX inspection. And of course, the area classification is a given. Where's this, we may be doing it in a facility, or it may be a skid package. So where is this actually going into? Is there any previous inspection records or schedules that we need to look at? What are things like the gas groups? What is the ambient temperature? This is one thing, the ambient temperature. The standard EX products, unless they're marked otherwise, are rated for -20 to +40. However, a lot of times when I go in and do an inspections, I can't get that information. I don't know what it is. It's not necessarily on some of the drawings. So I usually have to do some digging, because not all equipment is suitable for higher ambient or lower ambient conditions. Certainly the temperature code is something that I need to understand. Is there any environmental issues? Minimum IP ratings, is there material requirements? And again, that X condition, we'll talk about here in a little bit, we need to understand that as well. So again, without this information, it's kind of like just getting in your car and driving. You don't know where you're going. You don't have an address. I need to have a map to be able to get to that final address. So this information is critical for an inspector, and this is what every inspector should be asking. If you have to deal with an inspector, they're going to ask for this type of information. And hopefully this is something, if you're responsible for this, you can provide this information to be able to help, again, do a full inspection process. So again, it's the -17 standard, and we have 3 different grades of inspections. The 3 grades, if you will, are visual, close, and detailed. And basically a visual is going around and looking. So I'm walking around, and this is more from a traditional ongoing maintenance type process. I walk around my facility, and I could be just looking up at a light fitting, and I see, hey, there's water inside that light. Or I look at a flame-proof box and I see a bolt is missing. Or maybe I see something that's an unauthorized modification. We don't necessarily have to have a trained individual to be able to identify these types of things. This could be just a standard general worker, and we should try within our facilities to make sure that at least people, while they're doing a walk around in a facility, keep an eye out. Do we see, covers missing on a box or anything like that? If we do, that's a visual inspection. A close inspection is basically now we're getting up close and personal. So now we're going to use a step stool, a flashlight, a ladder. We're going to get very up and close. We're going to start looking at the labels. We're going to start looking, touching, feeling. We may touch a cable gland to see if the cable gland is nice and snug. We don't want to open it up if we find that it's loose, because we start opening up cable glands, we've now gone into a detailed inspection. And in order to do a detailed inspection, we typically have to go through some sort of lockout tagout procedure. So close and a visual inspection does not require lockout tagout. A detailed inspection does require a lockout tagout. De-energize the equipment. This is where we start looking at the inside of the equipment, and we're starting to look for things like internal faults. Maybe there's damage to terminal blocks, or maybe there's some damage to interior components, or maybe we see damage to a flame path, or gaskets missing, or things like that. There's also what there is called different inspection types. There's what is called initial, periodic, sample, and continuous. This is, again, all defined within the -17 standard. So initial is used to check that all selected type of protection and installation is appropriate. The standard basically says before equipment is put into service, it should undergo an initial detailed specification. So that's our first inspection. We're going to look at the inside. We're going to look at the outside. This is before it's energized. Before it gets actually energized, we want to do an initial detailed inspection. Now, a periodic inspection, this is carried out on a routine basis. This could be every 6 months, could be every quarter, it could be on a whatever periodic basis, you as an end client set forward, right? A sample inspection is where we're basically going out and checking out a representative sample. So for example, it may be extremely difficult to open up every single cable gland or every single light in a facility. But a sample inspection, we can go in and maybe take a look at a couple different cable gland types within the similar part of a facility with similar equipment, and we open up a representative sample. Now, the sample size could be determined by either, the standard doesn't really tell you, but it's generally 5% is kind of the number that is usually used as a sample inspection. If we go through and we inspect about 5% of the equipment, that's maybe 1,000 cable glands, we open up 5% of them and we don't see any faults, then we can pretty much reassured at that point that we don't need to open up the other 95%. A continuous inspection is done by a skilled personnel on a routine basis. So if we're actually going out to, say, a motor and we want to check something on a motor, well, while we're doing something there, we might as well do an EX inspection on this motor as well. So continuous supervision is where we're actually, as part of our normal process of maintenance, we're actually going to do an inspection as well on top of this. Here's one thing to note as well. EX inspections, people ask sometimes, do I care whether or not this equipment works? Is it an FAT, or what's the difference between a factory acceptance test? And here's my answer. I don't care if it works. I don't care if I flip this switch and everything is working wonderfully. I don't care if this PLC is doing what it should be doing. I don't care. What I care about is whether or not this particular piece of equipment or this set of equipment is going to be a potential ignition hazard if either during its normal or potentially in a fault condition. That's really what I'm concerning myself with. So again, as an EX inspector, really, we're not looking to see whether or not that this equipment is actually functioning the way it should be. We're really looking at it from, is this going to be a potential ignition hazard? That's really the focus of these inspections. So there's a number of different inspection charts or guides, if you will, for different protection concepts. And it's basically broken down into 3 different levels. There's one for D, E, and N equipment. There's one for intrinsic safety, and there's an inspection schedule for EXP. Now, you'll notice there are other EX protection concepts that are not listed here, But generally, those protection concepts are usually at the component level. They may be incorporated into, say, a piece of EX equipment, EXE equipment. For example, we might have a light fitting that maybe has a ballast, and the ballast is encapsulated. So we have M protection for the ballast, but the overall light fixture is rated EXE. So we're going to use the inspection schedule for E equipment, even though it incorporates some of these other protection concepts within it. So there's an example of what you actually see out of the inspection tables, if you will. So what you see over on the right-hand side, it's broken down into A, B, and C. A is for general. This applies to all equipment. You'll see on the right-hand side, you'll see things like EXD, and you'll see a D, C, and V. So that's detailed, close, or visual. So if I've got a piece of EXD equipment and I want to do a detailed inspection, everywhere where I see that X is something that I want to look for, right? So is the equipment appropriate for the gas group? I do a D inspection, a detailed inspection. That means I'm going to look at the label. I'm going to determine whether or not it's category under ATEX or EPL under the IEC EX is suitable for that environment, and so forth and so on. You'll see that there's some overlaps, right? So if you're doing a detailed inspection, there's a lot more checks. You do a close inspection, there's a few missing. And then if I'm doing a visual inspection, I may be just looking at a bare minimum. So it doesn't mean that I have to do a visual, then close, and then detailed inspection every time. I may say, you know what, on my initial, it's going to be initial detailed, but after a while, I'm going to go back out and I'm going to do a visual inspection. I don't need to double check all of this other stuff. This is where these charts really do come in handy. Then it's broken down to the installations. The first, again, was general. The second one, B, is our installation. So this is where we're looking at things like cables and cable glands and conduit seals and earthing cables and all of this other good stuff. So when we teach these courses to teach people how to become inspectors, one of the things that always happens, we actually have mock-ups where people come in and they will look at equipment that's already installed, and we've built a bunch of faults into it. And invariably what happens is that somebody will go in and they'll find 1, 2, 3, 4, 5, and then they'll hit a wall. And they'll go, I don't know what to do. I don't know what to look at, right? And I always encourage them. I say, hey, you have these inspection tables. This is going to help you do your inspections. Use them. And I've done many, many inspections, and I still use these. I don't have this memorized, but I'll go through and I'll catch all the things that I know on the top of my head. Those are the key things. And then I can usually take notes of those pretty quick. And then when I go back into it, maybe take a second look or something like that, I'll go and double check my list. And I'll say, hey, yeah, did I look for that? Did I look for this? Did I look for that? I want to make sure that I catch all these things. And then finally, C is the environment. And this is where, again, we're not so much on your initial detailed inspection, but it may be more for your ongoing environment. So when you're doing a visual inspection on maybe light fittings, you know, when it was initially installed, everything was fine, but now it's been out there for 3 years. What's the effect of corrosion or salt water or whatever it is? Are we finding that this particular product is not holding up very well, and we need to really take a closer look at some of this equipment? So it requires careful consideration of many things: the knowledge, skill, the competence of an inspector. You know, just because you've been doing it a while doesn't necessarily mean that you're doing it right, right? So you want to find and make sure that the inspector is qualified, has got experience, can prove that, give some sort of documentation. What is the scope of the inspection? Again, type and grade of inspection, what kind of documentation is available, the availability of facility personnel to assist, right? This is always key from an inspector standpoint, because if I start opening up things and I break something, well, guess what? That's my responsibility. So generally speaking, when I'm doing an inspection, I always want to make sure that there's somebody there with the company to be able to walk around with me and ask them to go ahead and open up things or, you know, do some disassembly. Is there the ability to de-energize, lock out equipment for a detailed inspection? Sometimes there is, sometimes there's not. Access to the equipment, and then of course, type of the equipment to be inspected and whatever environmental conditions that we may be running into. Here's the key thing, right? Safety is the utmost priority. We're here to ensure that the equipment and facility is operating as safely as possible. Do not compromise safety by any of the following. Using equipment within a hazardous area that's not suitable for that area. We don't want to take in things like cameras, key fobs, computers, unless we have a specific process in which we know it's a gas-free environment, or in fact, the equipment is suitable for taking into a hazardous location. Opening energized equipment in a hazardous location without a gas-free permit. We don't want to go up to the big red button that says e-stop and go ahead and start hitting it, right? So we don't want to operate anything without the facility personnel present. And here's the important thing, not recording anything you believe may be incorrect or unsafe. It is always better to err on writing something down if you think it's a fault, and then go back and double check later on. Check against the standard, check against the manufacturer's documentation, or what have you. If you think it's a problem, go ahead and write it down. And here's the other thing that I think is important that inspectors need to also be, is inspectors shouldn't be arrogant SOBs coming in and say that they know everything. And when I finish my inspection, I will always sit down with the client or whoever the fabricator is, and we'll sit down and we'll go through this and we'll talk it over. And sometimes you'll hear a good argument from them to say, hey, you know what, we did it and this is our interpretation of something. You say, okay, fair enough, I agree. Or maybe I say, nope, I disagree, the standard says this. As an inspector, you really should be open and accepting of criticism, right? But you should also be willing to dish it out. You want to do the right thing, because ultimately people's safety is involved in making sure that you're doing the right thing.
Okay, Bob, thank you.
Our first poll question. Yeah.
Poll question. Which one of these is not a great inspection? You mentioned those. So we have visual, initial, close, and detail. You guys, as usual, we are not going to judge you. You can click on there. One is the wrong answer or the correct answer. And Bob, I was wondering, I have a question. The hat you were wearing, was that EX certified? Now, nice picture of you working on that.
Yeah, that was on a LNG fueled vessel that was off the coast of Alaska.
So
and
pretty cold out there, huh?
It was very cold, yeah. But that was actually this was not energized, and there was no fuel in this environment. So, but I still had to carry a gas detector.
I can see you have a gas detector and a tablet, an EX tablet.
I had an EX tablet and an EX barcode reader or RFID reader because we had put in RFID tags on everything. So yeah.
Very nice.
Yeah, that was cold.
It was cold. Okay, guys. So let me close here and let me show you there is a mixed result here. So most of you answer correctly, right? Initial was not a grade of inspection.
Yeah, it's a type of inspection. Yeah. Initial is a type of inspection, not a grade of inspection. So visual, close, and detailed are grades of inspection. Initial, sample, continuous, and there's one other that I'm forgetting, is a type of inspection. So yes, so you the majority of you got that correct.
Yeah.
Okay, so let's show a couple different faults, and some of these are pretty obvious, right? So this one here, obviously you really can't answer it. I'm not going to ask you to raise your hand or do anything like that. It's fairly obvious, but this is on the land rig. This is a flame-proof box in which obviously the bolts are not installed, but they've used some baling wire to basically keep this enclosure closed. So at this point, obviously, we've got a major problem. A flame-proof box basically is designed to withstand an internal explosion. And obviously, if we had any gases and vapors get on the inside of that enclosure while somebody is tripping a breaker or something like that, then we could obviously have a disastrous situation. So That's pretty obvious. Now we would be able to identify that as a visual inspection, right? We're standing across from where this rig is, and I can see that from 50 yards away, and I can see, hey, it looks like there's some bolts missing here. That's pretty obvious. This one's not necessarily as obvious, right? One of the requirements is we cannot put Teflon tape, even though everybody thinks, hey, this is a great idea. But we're not allowed to put any type of Teflon tape on entry threads going into EX equipment. Now, in this case, it's covered up by a shroud, and a shroud is covering up the gland to provide some sort of environmental protection. And the only way to identify the fact that there was Teflon tape is to basically slide the shroud back, and then we see that there's Teflon tape. So therefore, that's again a situation in which the Teflon tape would need to be removed. So again, unless the shroud was pushed back in that fashion, we probably wouldn't be able to find this unless it was a close inspection, right? Because that shroud covering it up. And by the way, one of the things I would recommend, shrouds used to be extremely popular and to provide an extra level of protection around cable glands. I would highly recommend not using shrouds because quite frankly, all they end up doing is holding the dirt, contaminants, moisture against the gland. And what will happen over time is that brass or whatever material that gland is made of will start to disintegrate underneath the shroud, and you won't be able to tell. It's trying to protect it, but in reality, all it's doing is basically holding in the moisture and contaminants against the gland. And I've seen a couple applications where literally you walk up to a gland and with a shroud, and you touch the shroud, and all of a sudden it starts crumbling underneath your hands, and you realize that basically the brass is pretty much gone. So again, I would highly recommend not using shrouds unless somebody is just absolutely insisting that you must have them. So fault here, this is again pretty obvious, but it's not uncommon. This is where you might have a transmitter that comes with what is called a traveling plug or a temporary stopping plug. And this is basically installed in a lot of devices to keep, during transit, to keep contaminants from getting on the inside of an enclosure of some sort. And obviously, when this went to be installed, nobody removed it and replaced it with a certified stopping plug. So again, we've spent all this money on this beautiful transmitter, and it obviously cost a lot of money, but we have basically negated any EX protection on this particular product because we failed to install a certified stopping plug. And we would find that typically under a visual inspection. Now, this one is a little bit different. This is one where we look at it, we go, hey, that looks like a flame-proof product. And a flame-proof product requires typically a brass gland, a flame-proof gland, and typically plastic glands. We can find plastic glands that are EXE, but not EXD. So my first inclination would be, hey, that's a violation right there. However, if this had been installed in accordance to intrinsic safety, which you can find certain devices being installed as IS, then the requirements for glanding is slightly different. But the reason why this was not done as IS, because one of the requirements for intrinsic safety is where we would actually have some sort of tagging on our cable to say that this is an intrinsically safe circuit. The way I confirm that is that I go back and look at the drawings, and I notice that no, this is not being protected by intrinsic safety. It is flame-proof. Those glands must be removed and replaced with certified EXD glands. And again, this would be something that could be done as a visual inspection. Now, here's something that's a little bit interesting. You might see a label on products that will look something like this, and you'll see a bunch of different certificates. But if you kind of look from the left going to the right, you'll see on the far left-hand side, you'll notice that it's marked EXD, 2C, T5, T6, so forth and so on. There's a certificate for that. Then if you notice to the down and to the right of that, you'll see EXIA with a certificate. And then to the right of that, you'll see an EXIA, but that's for dust applications. And then on the far right, you'll see EXNA. So what this is basically telling us is that this device has been certified with 3 different certificates, and it's all the same device. But in this case, we have to understand how was it installed? In what zone was it installed? How was the installation done? Was it done under IS? Then we have to understand, we have to inspect it under the intrinsic safety requirements. Was it installed as EXD on the far left-hand side? Okay, well then we have to confirm that the glands are EXD. If, for example, we installed it in a zone 2 and used EXNA as the protection concept, then again, we have to look at different things. So generally speaking, you'll see on a label like this, and this is pretty common now, the manufacturer will actually put a check mark in those little square boxes that you'll see next to the protection concept, and that will give a hint or guidance to the inspector or the installer to understand, hey, how is this to be installed? How shall this be inspected? If we don't have this, then we have to do some more digging. And we would find this under a close inspection. A barrier gland in which the compound has basically not been properly packed around the individual conductors, we would find this only under a detailed inspection. We do not want to open up any glands like this under visual or close, because the moment we've done that, we have now lost our EX protection. And if that's an energized enclosure, and if there's a gas in the environment, then we now have basically negated that by just opening it up. So we would only do this under a detailed inspection where we've done a lockout tagout and we start opening up cable glands to start looking at the interior of glands. This issue right here is a little bit difficult to see. This would be found under a detailed inspection, but basically what we've got too much copper showing on those conductors that are going into those circuits. We shouldn't see that much copper showing, and typically we would use something like a bootlace ferrule to connect that to the IS circuits. We also see some clipped cables, and we also see some screens or armoring that's just floating out there. So we'd want to make sure, are we installing it as per the installation drawing? And again, good workmanship. In this case, we basically don't have that. So this we would find under a detailed inspection internal to the product. The fault here is the label is illegible, right? We just cannot read this. So when we see this, right, sometimes this is where we have to make our best judgments. We have to go in and take a look at it and see if we can read it. If we can't read it, then maybe what we do is have somebody go, or what the client might go in and say, hey, we're going to have to get a new nameplate, or at least put some sort of tag on there that reflects that we have documentation that shows that this product is still suitable for the environment. And we would typically see this under possibly a visual, but most likely a close inspection. In this case, we have water ingress on the inside of a light fitting. Again, we could have seen this based upon before we opened up the light fixture. We saw a bunch of standing water on the inside of the light fixture, right? So it could have been a visual, or maybe we didn't see it until we started doing a detailed inspection. We started pulling this apart, and then we see, we got all kinds of problems. So again, that could have been a detailed inspection, could have been a visual inspection, could have been a close inspection.
Okay, guys, we have one more poll question, making sure you are with us. What standard does an inspection follows? You mentioned this earlier, so we have 6079-14-1, -10-1, or -17. Only one, right, Bob?
Yes, there's only one answer.
There's only one answer. Correct answer. I marked down this while you were talking to make sure I had the right answer, but I knew there was a question. So
yeah, while you guys are answering that, there was a question that was asked: how do we deal with mobile phones and smartwatches?
yes.
It's a good question. There are manufacturers that will actually. You got to be careful on this, right? Some companies will have a safe work permit process that will allow you to take devices that are uncertified into hazardous areas. But generally speaking, what usually is the best approach is to bring in a certified product. And there are certified products that are Apple, Android, you name it. I'll tell you,
I've seen one in the exhibition recently. I don't remember the brand, but anyhow, they actually had a very nice smartwatch, EX certified for hazardous location.
Yeah. There's all different kinds and many different technologies that are out there, and actually, yeah, there's unbelievable technologies on some of the handheld and virtual handsets or headsets that are actually certified. The one
Here
thing
we go. This is the answer to your, I mean, what you have answered. So I guess 90% of you answer correctly, right?
Yep.
That 17 was the right standard.
17 is the right standard. Oops, my phone. I thought I put it on mute, but I didn't. But 17 is the correct standard or correct answer. So whoever, and I think a majority of you guys did get that. So just as an FYI, the 14 is the installation design standard. -1 is the standard for flameproof. 10-1 is the standard for area classification for gases and vapors. So here's one that's not so easily identified, right? This is a scratch on a flange, and this is one that could be open to interpretation. This would only be found under a detailed inspection. And generally, this would be one that I would say, hey, because it's not transversing from the inside to the outside, then we would let this go. But I will tell you, there would be some inspectors would say, nope, that's a problem, because a flame path has to be machined and it has to have certain tolerances. So that right there is definitely one of those areas that you could find yourself in a big argument with an EX inspector. So we would find that under a detailed inspection. In this case, this is also a detailed inspection. We're opening up some flame-proof motors and we see that they're, full of water. So we've got all kinds of problems here. We probably realized we went to go ahead and start this motor and nothing's working. We go and open it up and then we realized, hey, yeah, we've got all kinds of problems. In this case, again, we'd find this under a detailed inspection. What we find here is that the armor hasn't been properly secured to the inside of the cable gland, I should say. So at this point, then obviously would have to be re-terminated. Here's an issue where basically they thought that they were doing barrier glands properly by basically taking compound or pouring in compound after the fact and trying to do something like that. Unfortunately, trying to remove all that good stuff is going to be darn near impossible. But yeah, this is that's a problem. That's inside of a flame-proof enclosure. So again, we would find that under a detailed inspection. Here's one that's pretty common. And if you notice very closely on the certificate numbers down at the very bottom, you'll see a U at the end of it. What this is an enclosure, an EXE enclosure that is both ATEX and IEC EX certified, but it's certified as a component. And one of the things in the standard, it states very clearly in the -14 standard, is that we cannot install a piece of equipment that has a U certificate without further evaluation or part of an overall system cert. So what happens is that sometimes people will buy empty enclosures and they'll just populate them with terminals, assuming that they're A-OK. Unfortunately, in this instance, this was one that I did, and I had to tell them, unfortunately, guys, you cannot use this. This is not acceptable. A used certified product is not going to be acceptable. I'll give you a little hint that will also tell you that it's a used certified. Notice that there is no temperature code associated in the marking string. So if I don't have a T code on that product, that means the manufacturer didn't know what you're going to put on the inside of this enclosure. So therefore, that's also telling you, hey, this is a component certified product, not an assembly certified product. And we would find that under generally a close inspection. In this case, we have some intrinsic safety, we have some non-intrinsic safety, but it's kind of all bound together. So This problem is basically separation between IS and non-IS. There could be some damage to the flange. We can't really tell. It looks like maybe that's some sort of thread lubricant, which is always great to use. But we want to make sure that the flanges are in good condition, make sure that there's no scratches or any damage or undue corrosion. Here's an example of a flame-proof box in which a stopper box or seal fitting has basically rusted away, right? So we have lost at this point all the protection of that flame-proof box. And this is something that we should see very easily under a visual inspection. I inspected this. This was on a barge, and I saw this from literally about 30 yards away. And I walked over to it. I was like, holy cow. Obviously, the workers had no idea. And this was in a very populated area, if you will, on this ship. And it was something that guys would walk by all day, every day, and nobody made mention of it. Here's a situation where we have a gasket that basically has come out of its O-ring, its groove, if you will, right? Now, by squeezing it there, we have now violated, in effect, the flame path. We now have no flame path. We don't have the tight tolerance that we would normally have to have. So in this case, the remedial action is to replace the gasket with a manufacturer's recommended gasket and make sure that it's sufficiently placed inside that machined O-ring. The important thing to note also on flame-proof boxes is that we cannot go and put in gaskets after the fact. So don't go and start putting in gaskets on flame-proof boxes unless it's specifically been designed for a gasket, and make sure that if we have damage to the gasket, we replace it as per the manufacturer's recommendations. And this is opening up a control panel. And again, it's difficult to tell in this particular scenario, but we have a combination of intrinsic safety and non-intrinsic safety. And we have the wiring from IS right next to the non-IS wiring, and that's a major issue. So that's another fault. So an EX register, if you're not familiar with these, this is basically what an EX register will look like. And actually in the Q&A, I have another better picture to show you some examples of what you would typically find on your register. This should be available at the site for the plant or facility to have access to. Talking about some of the tools, the handheld devices and everything else, there are EX tablets. We sell these products. We have a Windows 10 tablet. We actually have an new Apple device for the Apple iPad Mini 6 that's certified. And then you have things like RFID readers and RFID tags that you can use. These are great tools and assets that you can utilize for your inspections. But you can certainly do it with the old, paper and pen as well.
Okay, one last poll, I guess.
Yeah.
Which one of these protection concepts does not have any special schedules chart? As you mentioned earlier, only 3, if I remember correctly, had a chart, right?
Yeah. Well, yes.
So
yes.
One is wrong guy here. Okay. We had a question that says, are throttle useful? Does that make sense to you, Bob?
Let me look at the question.
It was
cradles?
Cradles, yeah, sorry. It was put
yeah, Peter, I'm not sure what I understand by cradles. If maybe you could clarify, that would be awesome.
Yeah, please. Okay, so we have flame-proof housing for mobile phone. Okay.
Yeah. The housing for mobile phones. Yeah, there are some housings that you can buy to retrofit, if you will, over existing iPhones or Androids or things like that. Here's the thing. There's some people out there that are mislabeling or marketing these types of products. And I won't name names, but basically by putting a case on a product, it is a means of protection. And some of them are actually certified, but they're generally only going to be certified for Zone 2. But there are people that are basically saying, hey, I'm turning it into an intrinsically safe device by putting a case on it. And that's not true. You don't make it intrinsically safe by putting a case on it. And so there are people that are misrepresenting some of these cases to be able
Be
to
very careful.
be very careful. Yeah. Look very
Okay,
closely
Bob,
at inserts.
let's, no, because I've seen we're getting close to, 1 hour.
Yep.
And I want you to get to the end and also go through the Q&A.
Yep. So the
So
correct
what was the right answer? Was encapsulation, right?
yes, encapsulation is the one that does not have an inspection chart.
So, and usually you guys get it almost right.
Yep.
Okay, so
Be competent, go through an EX competency course. Realize you don't know everything. Again, don't let outside influences affect your judgment. And again, if you see something that doesn't look safe, report it to your supervisor. Here's the other thing, stay on top of your game, right? There's a lot of changes with the standards. They're always changing. The 14 standard is coming out next year, which is your installation design standard. And I will tell you right now, there's going to be some significant changes with regards to selection of cables and cable glands based upon the Dash 14 standard. So again, realize that standards change. If you're an inspector, you're a designer, anybody involved in the EX side of things, you really do need to make sure you stay on top of what's going on with regards to the standards. And again, safety does begin with you, right? Now, let's get into.
let me do this. Let me share the Q&A.
Okay. I have stopped sharing mine.
Okay. Daisy, do you see it correctly?
I see it.
All right, so guys, you posed this question through the registration process. Let me go through it. What is the role of the inspector quality control during engineering and design construction phases of the project?
Yeah, and
It's a good question.
it is.
Get to the
So ideally, the person responsible should be involved in the project specification and supplier evaluation. Now, a lot of times as an inspector, you're kind of coming in at the 23rd hour, so you're not necessarily involved at that early stage. But I do think that inspectors should have a say and be able to be part of that whole process with the design group, if you will. And it may be a situation like, for example, simple little things like maybe a particular cable gland, right? There are certain cable glands on the marketplace, again, without going into names, that are just a disaster to install. And there are others that are much, much easier. And if you're designing a project and you find that, hey, you know what, we're having all kinds of problems with this particular brand or this particular type of installation, as an inspector, your input could be very valuable to be able to make sure that we minimize those types of things at the very early stages. And then certainly making sure that the designers are aware of the X conditions, which we really haven't talked about, the conditions for safe use, because those can jump up and bite
let's
you.
see if he's coming back.
Yeah. So yes, that's a very
Okay.
important thing.
I'm not sure it was you or me, but I lost you or you lost me. But anyhow, here's the next question. Often initial detail inspection are split in field section and panel path, but that is not the end-to-end. Why is the approach still widely accepted by project manager?
Yeah, and that's a great question as well. The standard, what does the standard say? It says that all equipment must undergo a final detailed inspection, but it doesn't state exactly who is responsible or where that is to take place. However, some companies will in fact clarify this as part of their project requirements. And because of the fact, right, in some cases, it's always great to be able to do a final detailed inspection at a manufacturer's facility. If they're building a gas compressor skid or something like that, being able to do it there where they can make changes, fixes, and all this other good stuff before it actually gets out into the field is ideal, right? On the other end, same thing with regards to maybe panels or smaller pieces of equipment. Do it there. But as a final inspector, if I'm at the site and I'm doing this, then I'm still going to take a look and do a once over of the other inspector's work just to double check. And more what I'm going to be checking isn't so much of whether they caught everything, but was there some sort of damage that was taking place in between the time when it left the manufacturing facility and when it got to the site to be installed. So you know, there is a role, if you will, to do those inspections before it leaves a factory. And I always recommend that it is done at that point, because again, it's easier to fix the problems. But that doesn't preclude the fact that really a full detailed inspection should also be done. And some companies will insist upon it. But again, the standard doesn't tell you. It's more left to what is a best practice, if you will.
Okay, next question. Inspection on EXD barrier gland. Many of them are not able to be open for inspection due to their product with too much compound. We saw some picture of that. And many of them are filled up with too large cable. Is there an easier way to confirm?
Yeah, there is. I mean, there's different gland manufacturers that are trying to address this, you know, without pushing one brand or anything. This is on the left-hand side. Hawk now has an inspectable clear tube that you can actually do a inspection on, seeing the quality of the compound pour, if you will, on the left-hand side. On the right-hand side is actually from a company called CCG. On their cable glands, they use a bright yellow compound, and actually this picture doesn't show it, but if you slide up a little ring on the inside, you can actually see a clear compound chamber there that you can also see that the compound was all the way through this. So manufacturers are getting better with regards to making it easier to inspect them. And there are some new developments with regards to cable glands, barrier glands in particular, that some new developments are coming out that are actually getting away from the compound and the liquid resin altogether and going to more rubber type compounds to take the place of a liquid or a putty type compound. But yeah, those types of technologies are great to be able to do a better inspection on it.
I hear the term cold flow in regards to inspection of cable glands. Can you share details on this? What is cold flow?
Yeah, so cold flow is the process in which a softer material under compression will start to flow away from the compression. And this is a big issue with regards to cable glands. You could have cold flow on the outer jacket. Now, that's not such a big issue. It's still a big issue, but it's not as big an issue, but that's going to allow water to get on the inside of the gland, and we're going to have all kinds of problems. Where it's really a big issue, and if you go to the next slide, is that you see on the inner bedding of some of these cables, compression seals will actually start to deform the inner bedding of the cable itself. And those are really extreme examples of cold flow. So the way that manufacturers are addressing this from cable glands are basically using different types of seals to not put undue pressure on soft bedded cables. This is a big issue with some of the Norwegian soft bedded, low smoke halogen free type cables, because those cables have a fairly soft bedding compound. And so that bedding compound, when you put it under compression, it'll start to flow away. And so we want to try to minimize the cold flow.
Are there courses available to become an inspector?
Yeah, absolutely. There's two main ones worldwide that are recognized. One is called the IECEX Certificate of Personnel Competency, and then there's what is called CompEx. Either one of those have formalized programs that you can go to go through this whole process. You learn all the details about 17, you go through the inspection charts, and both of them will have practical aspects where you'll actually have devices where you have to do hands-on, tear them apart, look at it, find the faults and everything else. And we do both. We have a class this week where we're doing a bunch of people through CompEx, and then I think in 2 weeks, we're doing a bunch of people through the IECEX COPC program. The modules...
Sorry, Bob.
Yep. No, go ahead.
No, there was a question that, maybe, I know it's not possible to answer today, but it says, can you please share some example of a EX CompTC exam, to go for inspection exam?
Yeah.
Might have to work on a presentation of that.
Yeah, but I can basically tell you kind of some of the examples on the practicals is that you might see, you'll have like a flame-proof box in front of you, and every IECEX COPC group is slightly different, but basically you might find a junction box sitting in front of you, and there may be a damage to the flange, or there maybe the marking is wrong. Maybe it's not good for the gas group, or maybe it's not good for the T code. or maybe there's an unauthorized modification. Maybe there was a hole drilled in it that shouldn't have been put there. Those are all examples of maybe the faults that you might find under some of the practical faults, if you will.
Okay, how often does EX equipment need to be inspected? You mentioned something through the webinar, but
Yeah, so every 3 years is basically, if we use 3 years as the basis, that's what the standard. Now, Australia happens to use 4 years in the basis of theirs, but every piece of equipment should be inspected at least once every 3 years. Now, there was a big debate here in the US with the Coast Guard saying it had to be a detailed inspection, and that's not what the standard says. We can go up to a piece of equipment, do a visual inspection and say, hey, there's no undue change in the last 3 years, no corrosion issues. If it hasn't been changed, boom, we're done. We can do a visual inspection. Doesn't mean that we have to open up everything, de-energize everything every 3 years. It doesn't mean that. It just means that we have to take a look at it and do a quick inspection on it.
so
Now- yeah.
there's no mandated requirement to do a detailed inspection. You have to do detail if you find some problem throughout visual, right?
Yeah. So a detailed inspection is required at the initial, under initial detailed inspection.
Right.
Everything after that, for a piece of existing equipment, can undergo a visual, close, or detailed inspection. You would stick with visual or close inspections unless you see that there is something that's, hey, this is wrong. Something's happened here. Maybe it got replaced, or, there's something different than what you were expecting, or maybe the corrosion or the environmental has just created all kinds of problems. At that point, you might say, hey, I'm going to do a detailed inspection on this to investigate further.
Okay. I would like to know who gets to decide whether a set of enclosures are to be certified as EX. As control system supplier, what value addition can we do? I'm not sure about this question, Bob.
Yeah. I tried to write an answer down. Control engineer, you understand what the project requirements, T codes, and all this other good stuff. The bottom line is that generally speaking, under IEC EX, it has to go through a third-party certification. So the more you know as far as what the certification process is, what the testing needs to be done, then that process can go a lot quicker and smoother and easier, faster, cheaper. If you're doing declarations of conformity under ATEX for Zone 2, well, then you need to know exactly what are those test procedures, how am I going to carry those out, and that's your value added that you be able to provide at that point, certainly.
Okay, we are running out of time, but we have a few more questions to answer. Do we need to have specific inspection for EXI barrier connected field instrument for the requirement of meeting the minimum assurance task, MAT, for preventing, controlling, mitigating hazard?
Yes.
Yes,
We do need to. And the two things that we really have to pay attention to is if you see down on the picture below, in that case, they basically bypassed the barriers because they were blown fuses, right? So that's obviously something that took place in the field after the fact. So we obviously do need to inspect that. But the other thing is that when we're doing inspections on intrinsic safety, we do have to keep and make sure that we keep all these distances. We do all this good stuff, but we're also taking into account the length of the cable. And so what you see up there up top, you see a rolling up of excess cable, of IS cable. Anytime that we add additional cable to our loop, we're adding additional inductance and capacitance, which could exceed the maximum overall energy allowed within that loop. So we need to take that into account. The way we validate this is with what we call a descriptive system document, or our DSD, that will be made up by a competent person that will tell us, hey, this device has been matched against this barrier, and we cannot exceed this length of cable, and this is the cable that we use. And so it's critically important on IS circuits that we create these DSDs, and that as an inspector, we look at these DSDs to validate it.
Okay, this is a good question. Who can make a best inspector? A former designer or a former installer?
I love this one. Yeah, I love this one, right? And it is a great question. So my background's more in design, but I've done quite a bit of inspections. But my colleague, he was more an installer, and he's done a lot more inspections. And it's interesting because we find different things. or we look at different things. So I've learned from him and he's learned from me. And I think, you know, there is no right answer. I think you could be a great inspector, you could be a bad inspector, even though you've done both. So I think if you know, you want to have somebody that's obviously well-rounded, but the important thing is not having a huge ego, right? You got to make sure that you're willing to learn, willing to say, you know what, I just don't know. I got to learn this and I got to figure this out. And I need to talk to people and to get better, because I can tell you, I've done a lot of inspections and I will always run into a situation where it's like, you know, that's really different. I don't know. I got to do some digging on this. So that's the important thing, not have a huge ego.
Will part dash 14 and dash 17 be merged into a single standard? Is there coming up a new standard, Bob?
Yeah, I have not seen that being discussed. I did actually, when this was raised by one of the folks here, I asked of one of the committee chair people this question, and he said, no, there's no discussion about this. But 14 is the design standard, and 17 is the inspection standard. There is definitely some overlap between the two. There's no doubt. In the US, we'll never adopt the dash 14 standard because we have that within the National Electric Code. That's our installation design standard. But yet we have adopted the dash 17 standard, right? So I don't see that there's going to be this merge. I will tell you this much. For those of you familiar with the 14 standard, there is going to be, it's going to grow dramatically. And the 14 standard is going to be broken down pretty much into two different sections. One is going to be more around design, and the other is going to be more around installation. So I think it'll be easier to understand the new edition of Dash 14 when it's published, I think early next year.
Right. So guys, you know, we are running very late. If you cannot hang along, you know, you will get a copy of this slide later on. But anyhow, a few more questions again. Can you provide an example of a typical EX register, as I have to create a full EX register on our project?
Yeah, and there's an example. That's a real EX register that gives all the information, tag number, equipment description, manufacturer, model number, so forth and so on. So people can take this and basically generate an Excel spreadsheet. Mm-hmm. And this is what your typical EX register will have. The only other thing you might see on the very, very right-hand side, special conditions applicable. It says, yes, you might actually have another column that says, what are those special conditions? So anything that has an X condition, we'd actually put it out there. Or if it's not applicable, we put that out there as well. But that's an example.
Okay, well, I think we can end the rest was all, you know, can we do webinar or something else? Where do we find the webinars? They're all on YouTube. So since we are around 10 minutes late, one last poll for you guys. How did Bob do? And that's it for today. And thank you for hanging along. Thank you, Bob. You know, as usual, very, very interesting stuff. Some of these pictures make you wonder about going onto these plants and doing inspection. You know, you have to mark yourself before you enter those plants.
Yeah, and absolutely, if anybody has questions or if you need some further information, please just reach out to Paulo or myself. Be happy to help you guys in any way, shape, or form. Or if you've got additional questions that we didn't get to here, or just something that gets raised, feel free. Or if you need an inspector to come out to your facility and do any inspections, give me a shout. I'm very reasonable. So
yes, sure. Failure to share poll. I don't know. Something is wrong. It's not, oh, maybe it's working now. But anyhow, thank you for the excellent, guys, and see you next time.
Thank you, Paulo. Thank you, everybody. Ciao.
Thank you.